Welcome to Found in Space, a science podcast for kids and teens. Are aliens real? So this is Dakota's question, and this really is a million-dollar question, right? We want to know, are aliens real? Are there other forms of life? Are there other people, other civilizations, or even just other little microbes out there? And we have to start by saying, we don't know. We really don't know. We want to, it's fascinating, it's interesting, but humans, we have just barely begun to explore anything beyond Earth, let alone Earth itself. Every day we're learning more about our own planet and finding life in places that we never thought was possible before. Up in the atmosphere, down at the bottom of the ocean, in volcanoes, in salty lakes and frozen tundra. There's life all over the place. So the idea that maybe there would be life beyond Earth, this doesn't seem so far-fetched, right? There's actually a field of the space sciences called astrobiology. And astrobiology is all about trying to answer that question. Are there aliens? And if so, how do they survive? Who are they? Where are they? So astro means star. Astro comes from Greek. Stella would be for Latin and astro for Greek. So we'll see that in a lot of things having to do with space. An astronaut or astronomy. And today we use astro to mean space in general, not just stars. And then biology, ology is the study of, and bio is life. So astrobiology is the study of life in the stars. And it sounds poetic, it sounds amazing, and it really is. Now, whether life is in a star or not, that's another question, right? But how would we even begin to look for life beyond Earth? Now, if there are people in spacecraft zooming around the solar system, we might end up seeing them. Now, we haven't seen that. So little green men and crop circles and all of that, that's fun to think about, but that's probably not real, right? So what could be real? So when we look out beyond Earth, we look up into the sky and say near a dark area of the world, and you look up, you can see thousands of stars. Now, those stars are simply a tiny fraction, a tiny number of all the stars in our own galaxy, which probably has several 100 billion stars in it. And beyond our own galaxy, we think there are hundreds of billions of other galaxies, each with their hundreds of billions of stars in them. And the vast majority of those stars, we think, have planets. Probably many dozens of planets, if not hundreds, for each star system, if our own solar system is anything to judge by. So there's a lot of places that there might be Earth-like planets. And so what would we be looking for if we were to look for an Earth-like environment? Well, here on Earth, there are certain things that all life that we have found needs. And those two big things are water, right? All life that we know of needs liquid water. Whether we're talking about a giant redwood tree, a blue whale, or a tiny bacterium living in the desert. Everything that we know of needs water. Also, all the life that we know exists uses carbon. Carbon is an element. It's one of the building blocks for the stuff around us. And we are what's called carbon-based. So we use carbon to make the molecules. I like to think of elements kind of like Legos, right? Like little Lego blocks. You can take one block, let's say you've got a few of those little square red ones, and you put them together with some of the longer blue rectangle ones, and you put them together in different ways, and you can get these big, interesting structures. And then you can take them apart and make them into something new. Elements are kind of like that. So if we say that carbon is like the little red blocks, then all life has these little red blocks in it that we can find. So we'd be looking for some place that's got carbon and has got liquid water. There's some other things that would be very helpful for us to have, or for life to have on other planets. So they need some source of energy. And on Earth, the systems that we're in, that's the sun, right? So the sun shines on the photosynthesizers. Those are plants for the most part, algae, lichen, and they take the sunlight and they use it to help them take water and air and turn that into sugar. So that starts the food web. But there are other food webs in our planet that don't rely on the sun, like the living things at the bottom of the ocean next to the hydrothermal vents. So instead of photosynthesis, they rely on something called chemosynthesis. So they start their food web with the chemicals and the heat and the energy coming out of the center of the earth. So we'd be looking for a place where life could have a source of energy. We'd be looking for a place where life could be protected from radiation coming from stars and from space, and maybe some protection from things like asteroids and comets too, right? So here on Earth, we have that protection either by being in the water. Most life on Earth is aquatic. It lives in the water, deep in the oceans, or our atmosphere, that air blanket, that layer of gas held to the planet by gravity. So when we look for other planets, we might start by looking for planets in what's called the habitable zone, or the Goldilocks zone. This is the distance away from the planet's star where it could have liquid water on its surface. And so maybe if we find a planet that's about the size of Earth, it's in the habitable zone of its star system, maybe there could be life like us. Now we have a challenge at this point to find exoplanets. And we actually did an episode about that just a few episodes back about finding exoplanets. Now, here's the thing though. Who's to say that life has to be exactly the same as us? Maybe life doesn't need to be on the surface of a rocky planet. Maybe we could have life kind of like the life that we find here on Earth, but in other types of environments. And what about in our own solar system? So in our own solar system, there are a lot of places that are very, very Earth-like, but aren't in the habitable zone. Some great examples are what we call IWOWs, internal water ocean worlds. Earth is an XWOW, an external water ocean world, right? Our ocean's on the outside. But places like Europa, which is one of the satellite planets, one of the moons of Jupiter, or Pluto is another example. There's many places in our solar system where there are oceans underneath thick layers of either ice or rock. And they have liquid water, they have carbon, they have sources of energy coming from inside the planet, like the hydrothermal vents we were just talking about on Earth, that might be able to support life kind of like ours. And they'd have that extra protection where they don't have to worry about asteroids and radiation and things like that coming from space because they're underneath very, very thick shells of either water or rock. So we're interested in looking for life in places like that, where maybe it's there. Now, we're so new at this whole space exploration thing, we haven't actually been able to go down into those planets yet and go down into those oceans and look. And hopefully that's something that we'll be able to do in the coming years. Because at this point, we don't know. Maybe there could be whole oceans and ecosystems of life. There's also the possibility of life a little bit closer to home. Maybe on our sister planets like Mars, that Mars used to be very Earth-like, having an external ocean, the way Earth does now. And maybe if there was life during the time that there was the ocean, that life maybe has survived. But we probably wouldn't find it out on the surface because the surface is a very harsh environment. It's very cold. It gets lots of radiation from the sun and from cosmic sources, and the atmosphere is very thin. So there maybe could be life, but it probably would be under the ground. Maybe there are subsurface, so below the surface lakes, and in the ice caps. Another really interesting, intriguing possibility is that maybe on Venus there could be life. But Venus is really, really hot. You go down to the surface of Venus, and it's so hot that the few space probes we have sent to the surface have literally melted. But up in the atmosphere, up above in some of the cloud layers, there's an area where there's liquid water and pressures and temperatures very similar to Earth's. So maybe there could be life floating there, kind of like the plankton, the little tiny things floating in our ocean. So again, we need to go and look. So astrobiology is all about looking for that life. First, we have to figure out, is it there? What would it need? And we're only talking so far about Earth-like life. Maybe there could be life that doesn't use water, that doesn't use carbon, that lives at very different temperatures than us. We have to start somewhere, though. So we're starting by looking for environments like our own, and then coming up with ways that we can actually try to either go there or look at it with our telescopes and find out, could there be life there? Right now, we still don't know. Maybe aliens are very common, right? Maybe there's little life all over the solar system. Maybe we're alone in the solar system. Maybe the next star system over has a whole civilization that we haven't found yet. And we really are just starting to look. So that's one of the things that we need more scientists, more minds to be thinking about, coming up with ways to test. So astrobiologists. All right. So Dakota, thank you for this fantastic question. And it's one that we'll keep wondering about for a while. If any of you listening have questions that you would like answered on the podcast, take a look in the show notes for this episode. There's a link you can follow, instructions for how to send your question in. Get your grown-ups help with that, and let me know, what would you like to hear about? What space questions do you have? So as always, please stay curious. I hope you have dark skies, and I can't wait to see you next time.